Right, so what I'm going to do now is I'm going to show you how to how to compute a derivative using the definition of the derivative. So by definition, we know that f prime of x, the derivative of the function f of x, is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x over, right, delta x. So I'm going to use this definition to compute the derivative of the function f of x equals to x cubed. I'm sorry, not cubed. I want something nicer. X squared plus 3. I mean, we could do x cubed, but it would take a little longer. So I want to show you how to do this using the definition of this definition here. Now remember that f prime of x, what it does is what f prime of x does is that it gives me the slope of the tangent line at each point x, f of x, of the graph of the function f of x. So let's actually get started on that. So I'm going to substitute x plus delta x into f. So I'm going to get, so f prime of x then is equal to the limit as delta x approaches 0 of this expression evaluated here, x plus delta x. So it's going to become x plus delta x squared, okay, plus 3 minus f of x. So I'm substituting f of x in there. So it's going to be x squared plus 3. And this, of course, I have to divide by delta x. So now I have to expand this over here. I have to expand this over here now. So what is this going to become when I go through the expansion? Well, this is going to be equal to x squared plus 2 times x delta x plus delta x squared minus x squared minus 3, and this, of course, I have to divide this by delta x, and of course I'm taking the limit of this as delta x approaches 0. So I'm taking the limit of this as delta x approaches 0. So let's see what this is going to be. So we have here x squared plus 2x delta x plus delta x squared minus x squared minus 3. Well, let's see what I can do. Let me actually change the color here. So I certainly can cut this x squared with this x squared out. Okay, over here I made a mistake. I forgot to put this plus 3. Okay, there's a plus 3 here that I forgot to bring down over here. So let me just insert it in here. Okay, so it's a plus 3 here. Okay, so let me actually make this the plus 3. So we have minus plus 3 minus x squared minus x cubed. So we cross the x squared with this x squared. So I have really plus 3 minus x squared minus x cubed. Now what I'm going to do is I'm going to cut out the minus 3 with this. So I have plus 3 minus 3, so that just becomes 0. Okay, so now I have no x squared, no 3 here. So I am left with, let's see, I am left with, this of course is equal to 2x delta x plus delta x squared, and of course I am dividing this by delta x, right? So what I'm going to do is, and of course I'm taking the limit of this, I cannot forget that, as delta x approaches 0. So this really is going to be equal to, okay, I'm going to split this up, so I'm going to write this as, so of course I'm taking the limit, so this is, I'm taking the limit of this, okay, so this is going to, I'm going to write this as 2x delta x divided by delta x, okay, and over here I have plus delta x squared divided by delta x. Okay, so, and I'm taking the limit here as delta x approaches 0. So over here, just notice over here what's going on. I am able to cut or cancel this delta x here with this delta x in the denominator, and over here I'm just going to get a 1 down here. I'm eliminating, I'm canceling 1, and I am just going to be left with delta x, and I'm taking the limit of this as the limit as delta x approaches 0. So of course what I get is that this is equal to 2x. Now this delta x, as delta x approaches 0, just becomes 0. So we then have, as a result of computing this limit, that f prime of x is equal to 2 times x. So this is what the derivative of the function f of x, this is what the derivative of the function f of x equals to x squared plus 3 is. So f of x equals x squared plus 3 has, okay, f prime of x equals to 2x. So this is exactly what we wanted, and of course we are